So here we are, the three blondes here at the Wired Fest. Tell me, did you feel anything?
I mean, you can feel it, but it doesn't hurt, so you can feel that somebody's hitting you. It's not complete magic, but you just don't feel any pain.
Yeah, I mean, what is that like? I mean, this is this?
Yeah.
What looks like almost orange Play-Doh. It really does change its molecular structure under pressure. Now look at how squishy this is. Isn't that, I mean, it just is very soft and pliable. Now you girls, you have a little suit made out of the same material, yes?
And I'm fine.
And she's fine, absolutely freaking fine. Now Richard, you're the inventor. Come on, hop in here. Tell me about this molecule. I mean, this is an intelligent molecule.
It is, yeah. It basically knows how quickly you're trying to move it, and it doesn't like being moved.
So then it just goes...
It just locks together, yeah. It's very stubborn.
And you came up with this. How did you do that?
Well, as a previous life, I was a scientist,
Yeah.
and then I turned...
I was a rocket scientist, too.
Were you?
Yeah.
I didn't do a lot of rockets. Actually, I did one rocket, but that's another story. But I then got fed up with science, and I got involved in art. I went to the Royal College of Art, and then I left and started an innovation consultancy, and just got involved with lots of different technologies that were underutilised. And materials like this, not exactly the same as this, but you can get the same effect in corn flour and water.
Really?
Yeah, but you can't use it.
So,
well, you can use it to thicken your gravy.
That's usually what I do, but
Yeah.
some guy was telling me that I could mix it together and then I could, if I walked over it, it wouldn't crack.
If you ran over it,
Run over it.
slowly you'd sink into it and get covered in, corn flour and water.
Yes. Okay, that's an experiment we need to do. But I want to know, okay, so you were playing around in the laboratory with some gooey stuff and all of a sudden you went, oh, look, it hardens?
Well, no, I guess I knew about the materials, and I was working on a number of different developments, playing with some amazing materials, and at some point you get frustrated that you can't use it because it's still a liquid.
Right.
So I tried, you first of all tried to put it into things, and that really wasn't very effective. In other words, encapsulate it,
Right.
and then you can put it onto things, but it doesn't stay there. So I had to change it. So I just added the elastomeric bond to it, as opposed to putting it into something which is holding its own shape.
So here's Richard, and he's going to actually demonstrate this with his knee. So this is a concrete floor. We're in a convention center. It is, I verify right now before everyone, this is concrete. So Richard, you're going to do what now?
I'm just going to drop on my knees so I can...
And that did not hurt.
But it's in, we just built some trousers with it in. It's just in here. It's the same thickness as you've seen over there. It's really thin.
Right.
It's soft. You feel it.
Well, of course, it's the squishy orange stuff. So on impact, all of a sudden the molecule changes its structure.
It's basically, it locks together, and it really helps to spread that impact force, and it just absorbs a lot of the energy of the impact. Now, you still feel it. It's not like suddenly you've defied the laws of physics, but the shock absorption you get is phenomenal.
Fantastic. And so the uses would be sports.
Underfoot, very interesting for running, for sports where you can lower the profile of the shoe and still get that same phenomenal shock absorption. In gloves, in clothing, where you want the dexterity or the freedom of movement. In helmets, in soft beanies, which are not like a helmet, but a lot better than a woolly hat.
Well, yeah, I was thinking like when I ride my bicycle on Venice Beach, I might want to have a cute hat versus a helmet. And if I fell off, the cute hat wouldn't be helping me, but if I had your orange stuff in it, then...
Yeah, I mean, there's so many applications, and so you have all those helmets. The challenge with a lot of the applications is you have existing standards which are written around existing materials. So sometimes, you need a strap, and you need this, and you need that. So sometimes you think, oh, it'd be nice to make a product which satisfies the standard, but you can't, because you then spoil the product based around what it was, if that makes sense. So yeah, there's so many applications. A lot of potential military applications, industrial, footwear for metatarsal protection, and anywhere where you want that softness, but you also want the protection.
So what's next on the horizon for you?
Well, I think, in terms of markets, then we started off in snow, sort of ski, motorcycle, and we're just going to move into some of the North American sports, which are obviously a lot of contact sports, and then past that, the industrial and military markets, and then past that, potentially automotive, but by then...
Yeah, we just saw one of our best football players get hurt this past week, and if he had had this in his helmet, it might have been a different story.
Absolutely, yeah, and that's the future.
So once again, here we are with Richard, and we're talking about technology and how it's going to make our lives better. Thank you, Richard. You're really amazing.
Thank you.